All right, today's lesson is 10.4, which is radical expressions and equations. So we are going to look at solving equations that have a radical, which is that square root symbol. So these are just three examples of radical equations. So in today's lesson, I'm going to walk through the process of solving each of those different types. We're going to follow this set of directions to make sure that we properly solve the radical expression or radical equations. So first step, use our algebra skills to get the radical by itself. Then you're going to square root both sides so that you get rid of that square root or get rid of that radical. And then you're just going to check your answers at the very, very end. There are certain situations where your answer might not work, and we'll talk about that about halfway through the lesson. So we're going to start off with a fairly quick type of problem. So this first one right here. Again, first step is to get the square root by itself. So we want to get the square root of x by itself. That's being added to the 7, so we want to subtract 7 from both sides. And we can see that the 7 was not under the radical, which means we need to get rid of it. So then we're left with the square root of x equals 9. And then we're going to do our second step, which is squaring both sides. Whenever we square both sides, the radical just totally disappears. The x, the thing under the radical, does not change at all. And then that's going to be equal to 9 squared, which is 81. That's going to be your final answer. And then I want to remind you all that you can plug that back into the original equation to check and make sure that it works. And in this case, it does. The second one is going to be really similar. So we have the square root of x and then minus 5. That minus 5 is on the not under the radical, so we need to get rid of it by adding 5 to both sides. So that gets rid of everything on the left-hand side besides the radical, which is our first step, and then we're left with negative 2 plus 5, which is 3 on the right-hand side. Now that we have the radical by itself, we're going to square each side. Remember, whenever we square a square root, it totally cancels out, and we're left with just x, whatever was under the radical. And then that's going to be equal to 3 squared, which is 9. Again, check your answer by plugging it into the original equation. And in this case, it does work out, so that x equals 9 is an answer. That's all there is to those types of problems. But now we're going to look at two additional types where there's actually a square root on both sides. Since there's a square root on both sides and nothing else, then we're ready to actually go ahead to the second step, which is squaring each side. What's really cool about these types of equations is whenever we square each side, we're squaring two different radicals, and those radicals, the square roots, they just totally go away. So these problems are actually basically just a normal equation of 5t minus 11 equals t plus 5. See how we totally just got rid of those square roots? Now we're just going to solve like a normal old equation. We're going to subtract t, or 1t, from both sides to get 4t minus 11 equals 5. Then we're going to add 11 to both sides to get 4t equals 16. Divide both sides by 4, and we end up with t equals 4. And again, you can go ahead and plug that back into the original equation and check to make sure that that does work, which it does. The next one is going to be the same type of thing. So again, if both sides of the equation are completely under a square root, you don't have to do anything else, just square both sides and get rid of them. So you're going to do 7x minus 4 equals 5x plus 10. And then you're just going to solve it like a normal equation by subtracting 5x from both sides. So we get 2x minus 4 equals 10. Then we're going to add 4 to both sides to get 2x equals 14. Divide by 2, and we end up with x equals 7. And that's all we would have to do for that problem. So those are all of the more traditional types of problems. But now we're going to move on to some slightly more difficult problems, which involve quadratics. I want to remind you all about solving quadratics before I get started talking about the radicals involved. So this is an example of a quadratic equation. The very first step to solving a quadratic equation is always getting it equal to 0. So we're going to first subtract 24 from both sides so that we have x squared minus 2x minus 24 equals 0. Now we're ready to factor. So we want two numbers that multiply to negative 24 and add to negative 2. That's going to be x minus 6 and then x plus 4. But remember, whenever we're solving, we need to set each of those equal to 0. So whenever we have this x minus 6 equals 0, that means x equals a positive 6. And then for the second part, whenever we have x plus 4 equals 0, that means x equals negative 4. So that's a complete review from a couple of lessons ago, or last chapter actually, that we're now going to incorporate. But before we start to look at those types of problems, I want to talk about something that we call an extraneous solution. Basically, whenever we go through the steps of solving the radical equations, whenever we square each side, we sometimes get something called an extraneous solution, something that seems like it would work, but it doesn't actually. As an example of that, if we started with the original equation, just a plain old x equals 3, say we square both sides here and get x squared equals 3 squared, which is x squared equals 9. And then if we take the square root of each side, remember the square root is going to be a plus or minus version. So that would be like plus or minus 3, which would be positive 3 and negative 3. But again, the only actual answer was 3 because that's what we started with. That's kind of a weird example, but that's what we're looking at whenever we're identifying those extraneous solutions. So now we're actually going to start to check our work, and I'll go through that process a little bit more in depth. For this first problem, we're still going to go through those same steps as we had been on the previous page. So we are going to make sure the square root is alone, which it is. So we're going to square both sides. That gives us n squared on the left side, and then on the right side, the square root cancels out, so we just have the n plus 12. Now again, we want everything equal to 0 because this is a quadratic, so we're going to subtract n and subtract 12 from both sides to get n squared minus n minus 12 equals 0. Now we're going to factor. Our two numbers that multiply to negative 12 and add to negative 1 are going to be n minus 4 and n plus 3. So remember, we're going to set each of those factors individually equal to 0 to get our solutions. Basically, they're the opposite of the numbers that you already chose. So that's going to be n equals positive 4 and then n equals negative 3. But this is where the checking becomes super important. So whenever we go ahead and plug those back into the original equation, I'm going to check 4 first. I'm going to do 4 equals the square root of 4 plus 12. Well, that's going to be 4 equals the square root of 16. Well, the square root of 16 is 4, so that's 4 equals 4. That's good. So that n equals 4, that's an answer. But whenever we plug in the negative 3 equals the square root of negative 3 plus 12. So then we do negative 3 equals the square root of 9. Well, the square root of 9 is a positive 3. So in this case, that doesn't work out. So we're going to eliminate that option. So we only have n equals 4. For the next problem here, we're going to do the same type of thing. We have the square root by itself to begin. So we're going to square each side. Now that negative y squared, that's actually going to become a positive y, because remember, anytime you square a negative, it becomes a positive. That's going to be equal to, on the right side, the radical just goes away, and we have y plus 6. Now we're going to subtract y from both sides, and then subtract 6 from both sides to make sure this is equal to 0. We have y squared minus y minus 6 equals 0. And then we want those two numbers that multiply to negative 6 and add to negative 1. That's going to be negative 3 and a positive 2. Again, we want to set each of those equal to 0. So that's going to give us our solutions y equals 3, positive 3, and then y equals negative 2. Again, they're opposite of what you had initially found for your special two numbers. Now we do need to make sure to check, because sometimes we'll get one of those extraneous solutions. So we'll check the 3 first by plugging it into the original problem. Now for this one here, remember we started off with a negative y. So we want negative 3 equals the square root of 3 plus 6. Then we have negative 3 equals the square root of 9. And that gives us negative 3 equals positive 3, which is not correct. So we're going to eliminate that option. Now for the next version, the opposite of y, opposite of negative 2 is a positive 2. That's going to be equal to the square root of negative 2 plus 6. So that's going to be 2 equals the square root of 4. Well, that does give you 2 equals 2. So that one works, and that y equals negative 2 is a correct answer. So again, once you go through the actual solving process, just check your work so that you can identify if you need to cross something out as a possibility. Sometimes you do, sometimes you don't. So for the next problem, we're going to go through and do the same type of thing. So in this case, we first want to get that square root by itself by subtracting 8 from both sides. So then we have the square root of 3y equals negative 6. And then we're going to square both sides. Be careful whenever you square that negative 6, that turns into a positive 36. Anytime you square a negative number, it's always going to be positive. And then the square root goes away. Now we're going to go through and solve for y like a normal equation by dividing by 3. So we get y equals 12 for our solution. But I want to remind you all, we need to check our work. So whenever we plug that in, we end up with 3 times 12 under the square root, and then we have the plus 8 equals 2. Now, whenever we do that, we get the square root of 36, and then plus 8 on the outside of that radical equals 2. That's going to give us 6 plus 8, and we definitely know that 6 plus 8 does not equal 2. So that's not an answer. But the negative 12 was our only possibility. So in this case, it would be a no solution situation, which happens sometimes. So don't forget to check your work just to make sure things are going well. We're going to do that same thing for the next one. So I'm going to subtract 6 from both sides. That was a 6. So then we get negative square root of 2x equals 4. I'm going to, so that negative is a negative 1. So now I'm going to divide both sides by negative 1 to get that square root of 2x alone. And then that's going to be equal to negative 4. Now I'm going to square both sides. So then I have just a plain old 2x. And then that's going to be equal to a positive 16. Divide both sides by 2. And we end up with x equals 8 for our apparent solution. But then remember, whenever we plug that back in, we have 6 minus the square root of 2 times x, or 2 times 8. That's supposed to equal 10. So as we continue through that simplification, we have 6 minus 2 times 8 is 16. That's supposed to equal 10. So we have 6 minus, the square root of 16 is 4. Well, that's supposed to equal 10. But we know that 6 minus 4 does not equal 10. So that x equals 8 does not work. But that was the only possibility. So because that only possibility doesn't work, this would be another example of no solution. And that would be all for this lesson. Have a great day.